hit start streaming, and well, I might be live on one of the services. Yep, I'm live on Twitch, and I am also live on YouTube. Excellent. Sweet. I just need to make sure they're both muted. Awesome.
Now got a notification.
So this is my first time attempting a dual stream on both social media networks that I'm broadcasting on. So, yeah. Oh, the privacy on my stream is unlisted.
Oh, maybe that's why I can't see it.
Okay. How do I fix my being unlisted? Maybe I'm just not able to do that yet.
I'm gonna Google.
Oh, there we go. I found it.
Oh, okay.
Yep, this stream does contain paid endorsement, sort of. No, none of my content is fake. So... I saved that. I think I'm going to... Okay, I've started streaming.
That's a good song.
It's still showing a privacy of unlisted. There we go.
You think it's working?
It says I'm public. You should be able to see me on YouTube now.
Okay, let me go check.
Oh, apparently YouTube is kind of like vertical.
Oh, I see it.
And I'm horizontal.
Looks fine to me. Ta-da!
Yeah. Like, go to another room, turn on your audio, and see if the audio's okay and stuff. Please.
Doing it. Yeah, audio works.
Cool. Alright, let's get to work on the clock board. So, welcome to my workshop. I am working on a circuit board design, integrating a Xiao ESP32, well, actually, any Xiao module, from Seed Studio into a PCB that I'm making in EasyEDA. I've got a big copper backplane, circles where I would put, well, these glass domes would go in place over each of those circles. And inside each of those glass domes, goes one of these little circuit boards. There's a 9 set of them that hasn't been broken apart yet. Probably have one loose on the desk somewhere. Let's put a little more light on the situation. Ah, yes. Sadly, I don't believe I can bring that statue on. Excellent. I have 1 viewer on YouTube right now. Hello, wife. Love you. Okay. There we go. I can see both chats, and now I just have to find the board again. Get a little more workspace. And let's just look at it in 3D for a sec. Not bad. Let's get a better view of it. So it's pretty simple. There is a battery holder on the bottom. And this is a real-time clock chip that's connected to the SDA and SCL I2C lines for this socket, so that the time can be read and the time can be kept because we have a battery. So that's the one way to make a clock, but you still have to communicate with this in order to well, use it. So I'm going to add touch points onto the board. Alright, so let's add those to the schematic. So, a pad isn't really a component. I think there's actually a pad option in here. Not entirely. But I'm using a lot of great stuff that they sent me, so might as well. Let's see. What is this? A net label, short flag. Hey. Aw, thanks, Bela. Alright, what else in here? Tables, images. Oh yeah, there's a full color PCB screening, so we should try to get an image, look up how to put an image onto the board and actually put a cool, like, because you'll be able to see through the device down onto the circuit board. So if you were looking from above, you'd see down and, well, if I don't draw anything there, it'll be boring. this is what would go into the socket design on this board. That would plug in right here. I wonder if I can actually put the get that component in this view. That'd be neat. Let's see if we can do that. Oh, there's a couple of ESP32 C6, a C6 and a C3. So let's drop one of those in. Just to see what it looks like. It's sitting a little low. Let's see if I can... I don't think there's really a way for me to make this do what I want it to do. That's because it wants to use the surface mount template. That's fine. Nope. YouTube chat is separate from Twitch chat. And I think that they want to keep it that way. Yeah, you've been exploring the depths of licensing and privacy. Whereas I've dove head deep into the cloud ecosystem, and it's fine. I'm still free. Alright, so... I'm pretty happy with that design for now. How about a design rules check? It says, you haven't connected half your wires. What are you doing, buddy? Yeah, these are some pretty nonsense nets. I let auto route have its way with this board, and I regret that. A mess. Hello, Team Wildwood. Nice to see you. I'm working on a circuit board design here. Actually, multiple variations of the circuit board design. This one, let's get a 3D view going. This one would take the device on the bottom, just by soldering it onto these pads. Although clearly I have placed it in a bad location. Actually, I haven't placed it at all yet. Pretty well, I guess. As well as can be hoped for. Hunting for jobs in this economy. Where is that poor little... It's on the wrong side of the board. So the idea I had with this one was to put all the electronics on the back side of the board. I don't really like that. Yeah, I'm hunting for a real job. Hopefully making circuit boards and programming electronics and stuff, but I'm also still applying to some of the old traditional jobs a little bit. Ah, there we go. I've caught up with my own YouTube stream. Oops. Ah. Those are some good years, though. Definitely some good years. Okay. Now, this isn't the only thing I'm going to do on the stream today, but... So, I really like this design a lot better. I wonder if I can just copy-paste. Nope. Oh, that's one way to do it. Yep, YouTube and Twitch are completely separate for their ads. Alright, so these are the matrix connectors. 1, 2, 3, and 4. Okay. From this one, I need to copy just the circles. And we'll reference those to 0, 0. Back over here. Drop in our reference circles. Oh, great. I've made a mess. Alright, let's put those circles back in again. Thanks, son. There we go. The board outline, this purple outline, is not long enough, and we're in mil mode, so let's switch to millimeter. And we'll go with, I believe 150 is the length I'm using. Just check. Yeah, 150 by 40. Okay. I'm just going to open a second EasyEDA window. delete these. Oh, after I finish copying the... Probably broke in through the ceiling. I now have a concern that a cat broke in through the ceiling of my bathroom again. She likes to get up into the ceiling through secret places and make trouble. Alright, so that copies the work I did getting these in the right spot on the other board. And we'll copy the connections for the end devices. These are magnetic connectors that go on either end of the board. We'll use the bottom right corner of the board as the reference this time. Alright, and now I have my edge connectors on in the right spot. Move this over and flip it up to the top. And let's have everything on the top on this board. Turn the battery holder open or around so you can get at it. But that doesn't leave much space for the clock chip. Unless I stick the clock chip decoratively under the dome. Yeah. You just go there. So we have the radio crystal and its two capacitors, so that's... You gotta go real close to these pins. But I don't want anything in the yellow outline. Well, the yellow outline doesn't really matter, because it's going to be part of the case and held above. So this guy can go right like in the line. So I wonder, other than circles, like, what pattern should I get to put on this board? Maybe nothing for now. It's almost cramped. And if I want to make these repeating modules, I can't have this offsetting this. So that almost works. That would allow me to use a lot smaller footprint overall. Sticking the board on the bottom. Or even on the top. I don't think that would be fun to work with, though. Especially with this overlap here. So I'll just move everything over. Including apparently the board outline. Until it looks about even. Alright. So that reduces the board length to 125, 130. Yeah, we'll make it 130. And let's make sure that's on the perfect center Y so it lines up with its friend. And I want that to protrude so that it could connect to its partner. Make this bottom layer. Oh, this way I can put the clock. Yeah, I can put the clock right on top of the microprocessor so that the distance is super short through the wiring. Okay. Now to make a little more space for, just to make sure there's not pins coming through where the board ends up on the other side. I need to move this whole series of things to the right. So I'm just going to select them and then tap right on the keyboard until I have enough space here. All right, now let's figure out what this distance is. All right. Hmm. 2.826, so approximately 3. 78.54. So I'll just move them over by until they match the right size. back a little? Alright. Grab the next one. Alright. We need a slightly longer board now. And we'll move this connector over till it's at the edge of the board. Alright. What are these ones for? Okay, those are the SDA and SDL lines for talking to this guy. Which of your pins are SDA and STL? Those two. So we're putting in vias here, which are holes to the other side of the board. Those look pretty good. But that's almost too close because I need room. That should have stayed attached. Oh well. I wonder if there's a different line width this should be, because the pads are that size. Do the traces need to be bigger? I think this resistor footprint might be a bit big for what I need. Let's check the reference design for a clock. I know there's one somewhere. Somewhere on my Discord. If anybody in the audience is interested in PCB design, I do have a few coupons to give away for JLPCB if anyone's, actually interested in making a board. So we're going to take a look at the design on Open Source Hardware Lab. For a clock. So let's just open it up in the editor and look at how they did their communication passives on their clock. Is it going to open? Pretty cool. So let's see if we can find the clock in all this mess. Got the battery here. Let's hide some layers. Get rid of the solder masks. What layer is this? It's a copper region. Alright, so I hit all the copper. I see buttons, I see tons of LEDs. I'm betting this is the clock chip here. So let's save it into my own library of stuff. Just get signed in. I want to see what size resistors and capacitors are used in this design. So it looks like the one they chose doesn't require an external signal crystal. But they still have pull-up resistors, so let's just sanity check my design and see that I put in pull-up resistors instead of pull-up capacitors. Yep. I've got pull-up resistors. Excellent. Well, that's on SD and CL, which is where they should be. And yeah, they used 0402s, which makes a lot more sense. I don't need to be using the huge 0805s. So we'll go to the schematic and change out the resistor we're using. Let's see. I'll set the 0402 filter. And we'll just sort by what's in stock. And we'll just do a replace on those, which should make them a lot smaller in the design. Alright. Now they're itty bitty. Excellent. Alright, let's make that same change. How do I just copy the part number? Curses. Alright, I'll just copy the parts. Alright, that should update that PCB. Let me make sure I can see chat so I don't miss Sakura coming in. That's where the Toyota thing happened? That's hilarious. What a claim to fame for a place. Welcome in, and there's a shout out for you. Okay, let's check in on my other chat, which should be pretty empty. Where is it? I've lost it. I have lost YouTube. Where did it go? Try to do two things at once is absolute chaos. Hello, Nerded Art! Okay, somewhere over the rainbow is the correct browser tab. No, that's my... Okay, that's better. I accidentally got rid of one of the two chats that I'm trying to take care of right now. Alright. Oh no. All these things are no longer where I want them. So I will copy them back over from this document. Okay, alright, let's adjust the box yet again. Oh, we're back in mill mode. Do I have, like, several copies of this open? I do. Oh great, my two copies are now fighting each other. Alright. Not really feeling the PCBs right now. Let's switch over to some software development. Let's improve this device. Not necessarily as a sword, though. It doesn't need to be a sword. This is a wireless LED driver. Well, it's kind of wired, but that's because it takes a lot of power. But it talks to the network over Wi-Fi, which is quite useful. You can do OTA updates and stuff over the air, so you send new firmware to it over Wi-Fi. So let's open up the web page that it's hosting. I think it's on... Yeah, there we go. So let's get this. It's not very visible. Ah, it's pretty visible. Let's see what a little change in lighting will do. So we can program me now. Let's make me even more decorative. Right. Now, I have a misbehaving camera right now. We're gonna fix that. No more auto frame for you, camera. Alright. I'm a little wired, a little wireless. Let's make it even darker in here. Alright. Let's get me properly lit up. So we have a problem. Right now we have more LEDs than we have programmed to talk to. So let's get this segment light up. So I'm going to open up Arduino IDE. And we'll skip the library updates for the moment. Alright, how many LEDs do we have? 100? No, we have 144. And we are connected via Wi-Fi, which I can see up there, so we'll upload our changes. I have to enter a password to securely flash the firmware, which is nice. If somebody could just randomly flash firmware to it, that wouldn't be so good. So yeah, we've got this lit portion over here and dead portion over here. It's reversed for me, so. Alright, it's uploading. I should turn blue slowly. More and more blue. There we go, it's coming around my shoulders. But it stopped. Whoa, now it goes all the way around. There we go. Alright, well, I don't want to be green, so we'll push the button on the side of the case. And it can be different colors. I can be animated. But I am very green. I wonder if that's because the user interface is set for, I don't know, a specific color. Let's try being blue. Alright, so I'm a solid color. Oh, rainbow's still pretty rainbowy. Color wipe doesn't seem to do anything. You gonna wipe some colors? No? I'm watching the animation. And it's not perfect. It seems to stop every once in a while. I wonder if that's a problem with the code, or if that's just the way the animation is set up. Hello, Caro. So, we got confetti mode. Let's just make it very bright. Yeah. When it is very bright, it's very bright. Obviously. Alright, so 1% brightness. It looks barely lit, but you can see the color on my shirt. We'll bring that up a bit. Till the camera can't tolerate it. Camera, you'll figure it out. So, the problem is, these aren't very interesting or compelling animations. Right. It's just kind of like random popcorn. Nah. So, I don't know what to do about that. Well, let's plug this into something bigger. If only I had some form of light, this would be so much easier. Alright, almost plugged in. Wow. That's bright. Wow. Hey, DJ. Thank you so much for the raid. I am setting up a custom LED controller that I've been programming. To control the huge display behind me. I just set it for 100 LEDs, but clearly there's more than 100 LEDs there. I believe each one is 8 by 32. So let's just do a quick calculation. 8 times 32 times 4. So there should be 1,024 LEDs. Let's try that. So we'll just change the number of LEDs to 1024 and send across the new firmware. So behind me, those LEDs should go dark when it connects and then start filling up as it transfers over the firmware. Should be pretty cool. Hello, Geeky Heart. Muppets, who else we got? Well, that's the only people chatting right now, but welcome in, welcome in. We are doing silly programming shenanigans with programmable LED strip controllers right now. I was doing some PCB design earlier, but hello. Hello, Llewellyn. A tame mushroom? Whoa, that's bright. Okay. There we go, 1% brightness. Let's maybe go up to 3. So yeah, I've now got the sun behind me. If I make it dim enough, you can... There we go. So yeah, the main problem is it's too bright. Now, there should be a clever way to solve that. Maybe with 3D printing. So let's pop into Onshape and design a cover for the front of it that blocks enough of the light. Ah! Now, the problem is, I shouldn't design a diffuser cover for this. I should just put on the glass cover. Because, being a crazy person, I had a glass cover made for the front of that display. And then I said, you know, someday I'll 3D print some mounts so I can put it on. I guess that's today. So let's take a look at what it's going to take to get this expensive piece of low iron, absolutely filthy sapphire glass on the display. No, the glass is probably not going to help reduce the brightness. So, I do... Oh no, this glass is... If it's not dirty, it's supposed to be extremely clear. Like, it's low iron glass. So what I need to do is grab the diffuser paper I own. I'll be back in a moment. On my adventure over this way. Now, the problem with diffuser paper is getting it on there without any seams. So this is made for doing this. Let's see. I'll just grab another piece of tape. So when it sits away from the display a bit, it'll give it the right distance. Let's just tack this down for now, right on the surface. And then the piece with the diffuser paper on it is seems to be better. But if I do something silly and stick the diffuser paper to the front side of the glass, here, let's get some room here. So what I'm going to do is line up the paper with the edge of the glass. And then, like a barbarian, right on the desk. That is about the dullest razor knife in the world. I'm gonna get a different one. That's not a knife. That's also a very dull looking knife. Well, yeah, it looks like I was digging through plastic with this one. But I think this one has a spare knife, a spare compartment. So we'll turn on the light and see if I can... There we go. Huh. There's a piece of an old 3D print inside that. Well, I have a little tiny cutting mat. He's cute, but it's not big enough for what we're doing right now. All right, now how do I get this device apart? All right. There's wax on that. I think there's pasta on this? Maybe bug guts? I'm gonna have to get some glass cleaner. That's gross. This piece of glass was out in my garage for like a year. Well, this desk, it's wobbly. It deserves extreme violence. It has spilled so many coffees. I blame the desk. There's absolutely no responsibility on my side. Nope, not at all. I can hear it cutting. There we go. And you cannot see the scar in the desk, but you can feel it. Exactly, Nettist. All right. Even the paper's got goop on it. Just scrape that off. And we'll take another slice. That track was annoying. Get the edge as even as I can with the glass. Ruler, or other straight edge. I know I have a ruler somewhere near at hand that I can finish this cut off with and not tear the paper. There we go. This one I can do on the cutting mat because it's a small enough cut. Okay. So the problem is, I have a lot of length to cover. I'm using the wrong knife. You're saying I should be using one with a rounded tip. I'm just using what was ever loose. Did I switch to the blue rusty one? No wonder it's not working. That's why it wasn't acting very sharp. Well, that's me not being very sharp either, but that's his life. We'll peel this off here. And we almost have enough fuser material, or diffuser material, to cover the whole front. Just peeling off some old Scotch tape. At least I didn't set it down, like, under me. How many screwdrivers have I lost to setting them down on the chair beside me and then sitting up and then down and then... Where's the screwdriver? I don't know. Alright, this one's not cut very straight at that one end, but... or the right size at all. But if I have another sheet of this, which I think I do, that should be enough to cover the full length. Now, I wish this was the right stuff, but this is a single A4 sheet of sticky backed diffuser, which would be perfect for this application. Unfortunately, I only have one sheet of it, so it won't do. But somewhere in my pile of chaos, and strange materials, I have more fuser paper, I hope. Alright, with any luck, this isn't regular printer paper. What do we got? Excellent. That's regular printer paper. That's diffuser. Oh, I got tons of this stuff. I got 15 sheets. That'll do. Or at least I originally had 15 sheets. Oh, and some graph paper. That'll help out. The company D&D Automation no longer exists. They got bought and shut down, which is good because they had an abusive business model for young engineers. They would underpay as much as possible, as long as possible, to get the maximum value for their executives out of each and every employee. Lots of travel to the Great Blue Yonder for that. Alright, let's put down something as a cutting mat and stop totally abusing my desk. Oh, right. How about that big old ream of paper I just tossed off to the side somewhere? That should be flat enough. Right. I want to make sure it's lined up nice and straight with the glass. So. I slipped off at the end there. That's no good. But overall, better cut than the last couple. I am apparently terrible with the craft knife today. Though it could be worse. I could check myself. And then I'd be bleeding, and that would be no fun. Alright. We'll do a quick check and make sure, yep, YouTube is quite calm and peaceful. Technology is infinitely interesting. Which technology has caught your mind now, Basil? I'm just going to use the last cut piece and the ruler. Let's see how that goes. Make sure my fingers aren't in the way. Of course, it's not going to be a good cut if I keep starting and stopping, but I only have this tiny stubby 6-inch ruler with me. Just trying to focus. All right, that should be the length we need. Now, that one's got some, these guys have got some kinks and dents in them. That's all right. Hopefully they won't be too obvious. All right. Now I'm going to do a freehand cut. That's not bright. How about I put the, yeah, use your tools. And I'll use the grit on the cutting mat to get it nice and straight. And I screwed it up and cut it too short. Oops. Let's just put it in place. And I'll just barely touch it. That should get me a mark of the right length this time. see the mark. All right. Now the problem is, how do I join all these together seamlessly? And is that anywhere near straight? I wonder if I can just get it a little damp and it'll stick. So we're just gonna give it a little wipe down with some tap water. That way I can scrub whatever that is off it. Ew. Give it one last wipe, leaving it just a little wet. That's actually seeming to work really well. This should definitely look interesting if nothing else. All right. Boom. All right. So with the cover on, like this, it should actually be okay. I think I'll have to use a squeegee or something to properly apply it. So I will dig myself out of my pile of knife blades. Let's get these little guys stowed away. All right, spare blades are out of the way. Giant piece of glass is in the way. There, it's now I got a nice spot over on the floor where it's safe from me. Ah. got a spaceship stuck to my desk. The other thing I want to wire up is my Millennium Falcon. It needs lights again. Shouldn't actually be too hard. It needs a pin header connected to one of these and power, and then it can be pretty again. Alright, so I think I need some like clips that go over the end of that cover, well, the glass a bit. Yeah, you should definitely play with a YOLO model. Definitely play with training one. Figuring that out, that's the hardest part. You can just throw a YOLO model at most things, but training one to actually do something useful, that takes skill. I'm not sure I even have yet. Alright, so we'll make a sketch on the front plane. And how big is this thing? Alright, about 90 millimeters tall, and then it has a weird side profile. I'm gonna have to like trace this out. Alright, let's take a rubbing of the side profile. I have attracted a creature who says meow. Oh, what? Are you upset? Let me fix your spot. Let me fix your spot. There you go. There you go. Run away. All right. So this may look like nothing, but it is actually the real side profile of what we're working with. I think I have a piece of it loose somewhere. So, this is what that display is made out of. This is a piece of a chalkboard. It used to be mounted to the wall under a chalkboard at a school, and it would hold your chalk. But it's also a big aluminum heatsink if you have, say, a ton of LEDs you want to run. Uh-oh. It's just a set of screwdrivers throwing themselves on the floor. They can stay down there. Okay, so Actually, yeah. So the rubbing was pretty accurate. So we can take some measurements off the rubbing and put them in here. Okay, so what do we have? We have one big straight line. I can also just measure this object. So that is exactly 85 millimeters. Ooh, you got a nice shiny view of my head there. So we'll make a line. Oh, excuse me. There's some old concrete dust on this, and it's unpleasant. Okay, I want to get the midpoint of this, and this to be coincident. Thank you for the blessings. All right. Don't worry, I will not burst into flames. So, we have some weird angles going on here that I don't really know how to measure. I don't think I have a protractor. Actually, half of this is reserved for making a second one of those displays. It says so right here on the back in Sharpie. So this piece is coming off the back, and it is 20 millimeters long. And yeah, I don't know what angle that is, so oh well. I'll figure it out by measuring between these 2 points. Alright, so there is a... Okay. This is how many? Yeah. I'm going to say that's supposed to be 40 millimeters long before it gets bent all to heck. Ah, the throwing stuff on the floor stream, always popular. Okay, so yeah, that kind of looks like that. This is actually almost vertical here. That really does not want to stand up on its own. Okay. So that's probably about right. Now what's the thickness on this? 2 millimeters, and at the thickest parts here it's like 5 millimeters almost. Put that on there. Just straight on the ground this time. You can't fall off the floor. That is college knowledge. All right, let's make it offset. Okay, so that's essentially the shape of the metal. So, looking at that, how do I get this to stick onto something? So we'll add a little extra length here. Yeah, that should be long enough to get around the edges. All right, so we'll do offset again. Now that I've changed the lengths. Okay. Okay, let's bring this down with the extend tool. And then get rid of that nut. We'll slice off those. All right, so now we have sort of a profile. So that will be the exact size of the thing, which isn't very helpful. So let's see, how wide is the glass? The glass is 85. So. And how thick? I think it's a 1/4 inch thick, which is, I have no idea how many millimeters. All right, what do we have? Exactly 10 millimeters thick. Let's just do a couple of ugly boxes out here at 85. Right. Oh, that's a terrible design so far. Alright, let's offset these again in the other direction. Offset, we'll go at 4, and we'll confirm that. U2 can be the same point. Fill in these gaps I've created. Boop. Okay, that looks kind of sane. Close up the profile. So that will be a very tight fit, and I do not want that. So we're going to have to offset this guy. A 1/4 of a millimeter. Because that's about the precision of my printer to make a loose area. Alright, that's the original lines deleted. Let's add some fillets. That's gonna look nice. Yeah, I don't think that's gonna work. Why is it centered there? Okay, a little more rounding. I am making a bracket in order to hold a piece of glass to that display that's animating behind me. It's almost done because it's just a quick and dirty. We're gonna print it like 2 millimeters thick. Just as a test. All right. Can we do 5? No. It's a strange fillet that does not cut off the corner, but we'll just move on with life. Oop. Aha. You. And you. Be friends. Alright, that's plausible. And we're just going to make it super skinny. Well, no, I'll make it, yeah, 5 millimeters wide. And then, yeah, let's see. How do I export? There we go. Export. This is the marquee display clip that I'm creating here. All right, we have an STL file. Let's open that up in Orca Slicer, and then we can print it out. Well, that is certainly not the orientation we're going to print this in. That would be silly. Let's just auto-orient. And then we're going to do a arrange aligning to y-axis, which that is not aligned to the y-axis in any way. Alright, let's do something that would normally be silly. We're going to move this way down into the plane. We're getting a whole 1 millimeter thick slice. Let's make it even quicker to print. Do we want strength? Top shell layers? None. Bottom shell layers? None. Slice plate. Infill density, 0. Alright, it's just going to draw some quick lines so we can measure out if this is the right size. A 49-second print. Now, this is definitely not going to take actually 49 seconds. So we will take a brief break while this prints. I should probably abort that print unless I set the filament to clear polycarb. Ah, excellent. I already have the right filament, so we're printing in transparent polycarbonate. The B-cam is going for a little trip. Ah, I have the exact right number of filament rolls for a 3D printing hobbyist, which is apparently, survey says, 60. That's the right number of filament rolls to have. Any more than that, and you're being too obsessive. I'm joking though, but I was talking to somebody else and I counted up my rolls and I'm like, I have about 60, and they counted and they had 59. So like, I'm not better than them, but that's just, if you're into it, you get a lot. Alright, I need to get a drink. I'll be right back. Well, it's doing the dance of its people. Alright, we're at 99 degrees Celsius on the hotbed. That's hot. You got the Henry Ford color scheme going on. Let's get that camera aimed a little higher. I had another idea while I was out for break for the design. Let's see. I'll just work on that design a bit on the other screen. Kind of digging the royalty-free music tonight. Some of it's good. I have spent hours and hours watching this printer. Just zoned out totally into it. I was... Oh, I still have EasyEDA open. I should update my title. Boop. So, here's the EasyEDA design I'm working on. Let me find the physical representation of it. Probably floating around somewhere. There it is. So, this is a matrix display that I hand prototyped. And then I went on and I made these boards in EasyEDA. Somewhere on this desk I have half a dozen of them floating around. Here's one. So the boards go in here, and the circuit board I'm making is well, it lets me put 4 of these on a board instead of some janky hand soldered mess. It also includes, let's go into the 3D view. A socket for I had a couple of them on the desk, a SHAO module. So, a little microcontroller. Read it. Anyway, this is well, this particular one is a Seed Studio SHAO NRF 54L15. I tried to... Honestly, I learned EasyEDA first, and I find it easy. It's free, KiCad's free, so... Yeah, I import a lot of KiCad stuff into EasyEDA. So yeah, this is the matrix board. I've also included magnetic connectors at the ends. In theory, 2 microcontrollers. So one on here and one on the next module over can talk to each other over I2C. At least that's the theory. I may switch to UART. I have to actually wire it up on a board and test it. I know the running the lights will work though. That's not hard. That's data in, data out. Data in, data out. Data out, data in. Simple. So they are 1515s. SK6805-EC15 is the model number for the LEDs. I'll type that out. Actually, let me grab the link for you. What I'm making is a baseboard to plug these modules into. The modules are published as a open source project on the Open Source Hardware Lab, which is linked in the chat. Now, thank you, darling.
You're welcome.
A hot chocolate has appeared by my wonderful wife, leaving under the exit sign there. The print appears to have completed. Let's see if we actually got something. Well, we got something. It's not exactly what I expected. Is that... Ah. Okay, it's supposed to go like that. Well, let's see if it's the right size. It's the right size, but the angles are really bad. But I think it would work. Oh, I now have a hot chocolate flavored desk. So that idea kind of works. But let's just adjust the angles a bunch. Hey. And let's see if it actually fits over the object. Tea, 2 sugars, Yorkshire tea. You know, I bet if we looked in the cupboard, it might be up there. But if I wanted to be evil, I'd say, let's just microwave some water for tea. Just to make the British in the audience angry. No, this is properly boiled water. I'm not a monster. All right, let's see if this fits over the glass. Nope. It is too tight. I did not make the hole large enough, so let's see. Back into the sketch. We're just gonna set these to be forced vertical. Mm. 85.5. I should go to like 86.5. And then distance from here. No. And I'll just put the right number in, center that out. All right, that should be considerably wider now. You're from Yorkshire. Oh. Ah, yes. I promise not to abuse any tea. That's also really tight. So. Let's widen out this gap as well. We will force these to be horizontal just so they don't do any weird movements. Force that distance to stay the same. And we'll go up all the way to 9 mil. Want to maintain a minimum thickness of 2 millimeters on the front there. All right, that should work this time. Oh yeah, and let's just take a quick minute to update the what are we doing next? All right, now that I've corrected the stream info, I can continue my modeling without guilt. Now, because I've got clear polycarb loaded, I also have an idea for just making a faceplate out of the polycarb, because I'm trying to diffuse the display behind me. That's at 1% brightness, and I want to be able to go brighter and not blind the camera. All right. So I'm going to place a sketch on the top plane, and we're just going to make a big old rectangle. Let's tie it to the center point, and this distance will be 200, because that'll fit in the printer, and this will be 85. And then we will sketch a little lip on it. We'll make it 86. Alright. We want a corner rectangle from here to here. And we'll go 1. Do that on the other side too. This is going to give little lips. We're going to print this in a specific orientation, and it should make a ribbed diffuser that's very clear. Let's see, we want 2 mil. Oh, no, I actually want that to be 1. Okay, so that is the entire sketch. And this is 0.4 millimeters thick, or 2 printer layers. And then we're going to do another additional extrude, merging with all. Hide the part, so I can just touch these 2 little guys. And we'll go 10 millimeters. And that seems to have done nothing because I was hiding the part. There we go. And just for fun, we're going to do the tiniest fillet. Ah, hey, Wicker Man. Yeah, you'd definitely be able to judge. We do have quite a few friends from over there. Quite a few of them came in with the DJ Unreal raid. Uh-oh. Okay, so well, thank you so much for your lurk. And come on, fillet that edge. I don't know why those couldn't be the same fillet, but that is essentially the entire part. But I need to find out. Nice Super Meat Boy. So we have Hull, Quebec, and it does smell like Frenchman, but the place that smells the most in Canada, it used to be Hamilton. There was a lot of steel refining. When you drove through Hamilton, you'd roll up the windows, put the air on recirculate, and just pray you didn't have to smell the sulfur stench. Alright, I need to measure the marquee display's total length, and then make these divide into it evenly so I don't have, like, some weird number of them. I'll just measure the glass since that's what we're actually covering. 955 millimeters. So 955. So they need to be 191 millimeters long each, and I need to make 5 of them. Alright. That's an easy fix. Alright, they're now the right length. Let's rename this to yeah, we'll just call it diffuser. And we will export the diffuser. I don't know why it zipped it. Alright, so I need to see. So that's just gonna fill the whole bed. But I need it to do a very specific pattern. Alright, now I need to get rid of the rotation. Make sure we're using cling plastic for a window craft idea. I guess maybe thin vinyl or something. I mean, this plastic diffuser paper clings to that glass really well. But we also used like weird cling gel stuff from the dollar store for Halloween, so yeah. So what I'm trying to get going on here is when it places the lines, I want it to do it in parallel with the structure of the object. It won't be a strong object. But it should be pretty. Let's try monotonic, see what we can get. Yeah, that gives me a diagonal pattern, which is not what I want. probably only care about solid infill pattern. Yeah. Alright, solid infill pattern. Alright, outer stupidity. Nice. It really wants to put a brim. No brim. This should be incredibly fragile. All right. Oh, I better go clean the crap off the printer. So what I've got here is something I get every time I print. And it's a good thing, because you can see as it starts to come out of the nozzle, it's a little nasty, and then it gets a lot nicer as it finishes its purge. This is Clipper Adaptive Multi-Purging, or Material Purging, which makes for good print starts, because otherwise the garbage part of this ends up being like the very first part of your model and it doesn't stick to the tray. Now, if you want an idea of how many prints I've done, this container has almost one stick for every print I've ever made. So, as you can see, it's so full, I can't get more in. So I need to print another one of these. That's, yeah. I love 3D printing. Okay, let's kill off the music and change up the title. We're gonna do some roguelike games while we wait for this half-hour print. I'm going to see if I can demonstrate Megaloot. Megaloot break. Alright, we'll even change the category for this segment. Okay. Ah! Okay, so get off my head. Let's go for the internal one. Oh, that camera doesn't exist. Okay. Back to the 3D printer for now. Oh no. I've lost the scene. I think it was this one. Yeah, this one's hands, head, and 3D printer. There we go. So what we're going to do is bring this over. And bring that in here. Nope. And then we will shrink my head. Ah, I'm shrinking! Because my ADHD dictates that we can't just play a video game or 3D print. We have to try to do it all at the same time. Alright, how do I do this again? I create the game capture and I name it. And then I turn on the video game. Alright. Let's get Twitch chat back over on a screen I can see. And of course, it does not see the game. Oh, that's better. I have more things in the list. No. No. Okay. Get that back. Oh, hey, people are actually on the YouTube chat now. Yeah, I don't know why it tried to put a skirt on that flat print. That was kind of nonsense. Yeah, but for now we're doing... Huh. I have a totally different scene. Ah. I am way behind. Alright. we are back up to real time on both my chats. So we're gonna get some Megaloot going on while the printer does its thing. It's doing a homing routine right now. So I will pick this character. They seem to have a bonus to their magic attack. Megaloot is mainly about collecting loot. So I'll start with a little bit of equipment and enter the dungeon. And I've got a cute little frog. He wants to, unfortunately, fight me though. So I fought the frog, and he dropped a helmet. Alright. I should buy a magical stick. Alright. So I now have my magical stick. I do 5 magic damage. But if I buy another common magical stick, they combine. And I have an uncommon magical stick. Yay! I can get new items available in the marketplace by refreshing. And then I can fight the rat. And a cute little pebbling. Alright, the printer has started printing. I'm just going to take a look at it. The problem with printing transparent filament is you can barely tell you're printing transparent filament. So we've come to a merchant. They tend to sell some interesting items. So this item is special because it gives you 20 armor multiplied by the number of staff items you're wearing. So if I put that on and then get some other items with the same same item class, it'll help me out. Oh, there's a upgraded magical stick I can get, and I can get my helmet upgraded. I'm all blue now. I'm not wearing any pants yet, so pants help. And if I collect leather chest plates, they can stack together and then upgrade the one I have. So I could get more money, or a chance. Just carrying this gives me a chance of getting an extra item when I open a chest. Chests are pretty rare, but why not? Alright, I've got a level 1 bat, and no money, so we'll fight the bat. This goblin wants to steal and leave. So, hunter's pants. So I now have 77 armor because this gives me 60 because I'm wearing 3 different things that have the staff symbol for the mercenary set. I'm going to refresh the market, and so a rare magical stick that gives bonuses based on wood class stuff. Yeah, no thanks. A ring. And we'll do a bit of fighting. Alright, the print is still going along nicely. Alright, so... I swear my money just ticked up while I was looking at it. Must be imagining things. Let's sort through. I can sell things I don't intend to use. I want to collect things that have magic-related attack items. So we'll refresh what's available. Magical hat, magical shoes. That's a good deal for this character, but I have to defeat whatever I'm fighting and move on before I can change my outfit. Which kind of makes sense. Changing your outfit in the middle of a fight wouldn't be very tactically advantageous. We get the training sword, which we'll sell off. There we go. That's what I want, is this staff. I hope I can sell enough stuff to afford it. Doesn't seem like it, but I'll just sell everything I own. So I need 524. And I'm not gonna get there with what I've got. That's unfortunate. That looks really good. So, another armor multiplied by number of items in the set gives me a huge amount of armor for what I have on. We can just sell my old pants. And buy some cheese. Cheese lets the merchant change things for you. We'll buy the magical cloak. Alright. I'm gonna just take a close look at the print again. Well, that was dumb. Alright, gaming break's over. Let's get back into some more exciting things. OBS, where are you? So, it's just making a mess in there. I don't think I should let the print job finish. But I do want to peel off that piece and see what it looks like. So I'm just going to send a pause over to the printer and we'll pull out this mess. Woo! That's toasty. So we have a bit of an issue here because I don't have polycarbonate tuned very well. So, ooh, that's super sticky. Not sticky? Staticky. That was neat. But yeah, I think I need to tune the pressure advance because that is terrible. So let's actually run a pressure advance tuning and see if we can make this not print garbage. The other problem was it printed the camp line like inside the object because I guess it didn't have space. But the whole idea behind this was to see if I could print a sheet of diffuser. Well, let's put a little double-sided sticky tape on it. We'll just go one-sided. Well, it's so clear you can barely tell it's there. Now let's go over to the control web page for the strip, wherever that ended up. There we go. And that's just bright. So we'll turn that down. Yeah, you can sort of tell there's a cover. That's twinkle. Let's speed that up a bunch. Now, on the camera, it looks like big lights, but it's just a single individual light lighting up, making those star effects. So that's kind of fun. Okay. So let's get chat back on a screen where I can see everybody. There's one chat. And there's the other chat. All right. Put the 3D printer back together. All right, so I want to fix the issue I'm having right now with my 3D printer. So let's go over to Orca Slicer, and we're going to tell it to run a pressure advance calibration. We are running a direct drive extruder. Let's get the right screen up. So we're running I've opened Orca Slicer and hit the calibration button at the top here and chosen pressure advance calibration. And we're going to use PA lines. We're going to print the numbers. All right. You can't see that very well. So what this is going to do is work its way through different pressure advance settings, and then these lines back and forth will be either solid or have gaps in them if the setting is correct. And this will let me print cleaner cases in this particular material once I find the right settings to adjust pressure advance in here. There it is. So pressure advance is set to 0.08, which is this guy on the test. But I'm going to assume that's wrong because we're getting absolutely terrible prints. So that should take about 5 minutes. In the meantime, we are going to work on the casing for the PCB. Okay. Alright, so this is 3D shell design for the matrix modules. And we will switch back to science, because science rules. Okay. Go back to the Onshape library. So this is a broken design for one of my case models. I think it may just be better to start over. Yeah, so I wanted to build based on this design. I wonder if there's a way to export this. I'm sure there is. Aw, if Kaon's rating me, that means I missed a Kaon stream. Darn it. Welcome in, Raiders! Kaon, thank you so much for the raid. I'm working on a casing design for this circuit board that I've put together. Hello, hello, Kaon. Thank you. Welcome in. If you have to raid and run, that's fine. But thank you so much for the raid. So, yeah, this is the incomplete board, but I think this is the right size for what I want to model. So let's see if we can get this exported as a... Okay. Outer 3D shell. Yeah, because I don't have any shell objects. That makes sense. Okay. Let's see if we can get this into Onshape. Apparently there's an unbound model. You, what am I going to bind you to? I don't know what I'm doing here. It says please select one 3D model, but yeah, I'm just gonna cancel that. Well, have a great meeting. Let's see. We've got this exporting. We'll export it to downloads and open that sucker up. And whenever it shows up, oh, it's probably already there. So that design is toast. We're going to create the 4-tube matrix case. Yeah. And I will again hunt down the escaped YouTube window. There you are, YouTube. Hello, Terry. Wonderful to see you. There we go. Now the chats are sitting sane. Let's do an import. And see if it imports. Like, what are we gonna get? Failed, uploaded but failed to translate. Fair enough. Oh. Hello, Bun Life. Yeah. A little bit of YouTube inception. All right. Back to the 3D preview of this. No, not that one. This one. Now, export. We'll try a step file this time. Alright, let's see if we can get a reasonable object into Onshape that we can just trace. It'll make making the case a lot faster. Oh, right, where did that save to? I'll just export it again and I should be able to find it after that. Okay. Processing complete. Continue to export and... Okay, yeah, no, I stuck that in downloads. As a step file, so back over to Onshape. 4-tube matrix case, and add imports. We'll delete that broken one, and we'll try to import just that step file there. And I'm crossing my fingers and hoping the file works. Come on. Okay, import A. That looks like it worked. Sweet. probably want to move this part in the actual design, but I'm pretty happy with that. Okay, so we'll go over to Part Studio 1, and so we'll insert that into an assembly. And then what I'm going to do is just make a big sketch on the top plane of a rectangle. Assume that's 150. So that'll probably be the size of the object. Let's do an extrusion. We'll make it 2 mil thick. And then let's insert this random part into here. Alright, I'm going to put a snap connector right on the center of it. And then one on the center of here. Mate connector, there we go. And then we'll do a fasten mate just to force those to stick together. Boom. Well, that kind of left some things floating in space, but that's alright. I just needed to get the board outline. So that we can use this trick. We're going to edit in context. Edit in context. And that allows me to draw the board on top of this sketch. So I can take the project tool and just grab that board outline. Alright, and I want a little bit of space around the board. So we'll grab the whole chain. And I'm going to make the walls 2 millimeters thick. Just like I made the base. Like right now, we're just making the most bog simple box. So let's take a look at what the height stack up on one of these is. Sitting inside one of these connectors. Sitting inside one of these glass jars. Alright. So looking at that, we got a distance from the surface of the board. It's going to be the bottom of this connector. So how far above the board, we want the top surface of the thing. So that's about 12 millimeters. And then, so 12 millimeters to the top, and then there's like a 3 or 4 millimeter margin at the bottom. So it needs to sit no thicker than 10 mil above the surface of the board. So but I mean, that's terrible design. That's just a box that's so tight on the board you can never actually get it in. Now, because I copied that outline originally, it's kind of upset about my changing the distances. And okay, so we've freed ourselves from the constraint of the original drawing. I want, let's give it a whole millimeter on either side. Oh, that didn't work because I need to make a bunch of stuff perpendicular here. Okay. What do we got? We brought over the holes from the board. No, they're just on the board. Okay, that's fine. Okay, so when I make this horizontal, vertical, now when I make this 21, it should stay on angle. Yeah. And I'll just move that. And things decided to get a little weird. My lines didn't want to stay connected. I don't know why. Alright, so that gives me an extra millimeter on either side. Alright, let's go with I change that back to a driving dimension, and then we'll make it 68.5 as well. Okay. Let's take a look from the top. So now there's a margin. And the board's not going to be able to sit right on the bottom of the case. Especially if I put the battery on the bottom. Now, unfortunately, it didn't bring across the silk screen I need for locating the domes. So I have to, I guess I can sketch the domes again on this. Sure. So how big is the dome? Well, let's find out. That is almost exactly 25 millimeters at the thick part, and then we actually go down to 23 at the body. So what I need is a line through the center. And coincident. Okay, that was already coincident. I just was looking at it from a weird angle. Alright, so I need a center point circle. We'll center it approximately there. And we'll make it 25. I'll get way zoomed in just so I can make sure it goes where I want it. Right there. All right. So that is the size of the larger part of the base. I think I want the cover to be able to retain the device, the glass. So we'll go with we'll make that one 25.5, and then we're going to use the equal tool so these stay the same size. And then there's a distance from yeah, that's actually about right. So those look like they're all lined up as I'd expect them to be on the board, which shows me that on the board I actually need to move them all left a little, because this doesn't look very even. Okay, so I'm looking at context 1, but I just want to look at the assembly. Well, right now it's not a very good part. It's a rectangle. those should be the same part. So there, now I've got a bucket. Yay. All right. Alright, now this needs to be Alright, let's go into the sketch and get rid of all these, make these construction holes. Okay, clear selection. That's for construction. Can I set that? Alright, clear selection, just get the hole. I cannot set it. Alright. Fine, I'll just select these because I cannot figure out why they are in the drawing. And let's put some music back on. Oh, right, back to having some music. Okay, we won't make this. What? That is not what I expected? I see what's happening. I need to only be able to get the things in the sketch. Okay. Yes, that is exactly what I wanted to do. So I would like to delete that circle. No, you can't delete that circle. So let's just hide the part. Why is it I can't delete the circle that's in my own drawing? Probably because I'm in a context? How do I get out of the context, though? No idea. So just delete that extrude. We'll do oh, that's why I can't edit it, because it's on the face of context 1. We'll move that to top plane. That's better. Now I don't have holes I don't understand in my part. But without that, I have a problem. There we go. We need this to be 12. Alright, so I think I have a prototype of this around here somewhere. I don't. So I want this to not pass through. Alright, we will make this the top. Oop. That part, no, yes. Okay, so that has the right size holes in it for this to slip through. The holes need to be then closed up with another layer here. So we'll put a sketch on this surface and we'll name it dome seal. that. So 24, 25. Edit that. We're going to project in these larger holes. Boop. And then offset them. All right, so I need to go from 25 down to 23 or so, 24. We'll just go 1 mil in. And we'll just repeat that. No, it's not. That's actually because it's designed on based around my circuit board. My circuit board's wrong, so that'll get fixed. Well, I do. But only a little. Alright. One. Okay, we can only offset one thing at a time. Okay, well, let's... Let me offset, please. Fine. -1. Good. Enter O. -1. -1. Alright, what do we got? We got 4 holes now. That seems reasonable. Then we'll bring back in the outside. And we're making this yeah. Well, I'm just learning PCB design, so this is all new to me. Alright, so that's going to want to hold itself down like 5 millimeters. Ooh. Wait, 5 millimeters isn't a long way. This step needs to actually be... Yeah, what happened here is, well, it's offset in this design, which is the problem. Or is that even the design I'm using? Yeah, I think I'm using this design. So that's 21 from the edge. And that's 22.5 from the edge. Okay. So I want this step. So we'll change this to up to next. Face. Right? What is going on here? So that should be the big holes. What am I doing wrong here? Ow. Inches? Where do we have inches? I'm only using metric here, man. I swear. Okay, so. Oh, man, I must be getting tired. It is 3 hours and 40 minutes into stream, so I have my excuses. I am doing an evening stream today. I was hoping to give a wider audience. I do morning and then evening streams so that people on any part of the planet can hopefully drop in. Alright, so we got faces of dome seal. We want that 1 mil thick. But I kind of want it to be a bulge and not like a surface plate. So we'll go back into the dome seal. And we'll bring these back in. Let's just get a straight on view, and we're just going to grab these little donuts. Now, you may find when communicating with Canadians that we do use a huge mix of units. Metric, imperial. We'll spell something any which way that works for the moment at hand. I mean, we talk about temperatures in Fahrenheit and Celsius quite frequently. My oven I set in Fahrenheit, but my thermostat I set in Celsius. I talk about my height in inches and my weight in pounds, but that doesn't make sense Okay, so don't think that's what I want. And now I've got 4 separate hoops sitting on the surface here. That's not actually what I want. Let's see if we can cheat with the fillet tool. Nope. So we'll go back to that extrude, and we'll have it in addition. Yeah, I think that's sort of what I want. This song is annoying me. Yeah, pool temperatures. Fahrenheit for food degrees. That explains it. All right. Not doing what I want. I'm trying to get a nice, like, organic edge to where it comes up out of the surface. Offset tool. Okay, come on, offset tool. We got a 1. All right, we've offset our tool. Now I need to get rid of, or yeah, we'll make these middle lines construction. don't want any of that selected. Extrude 1, edit, clear all that. Show the part again. Okay, yeah, that's... Oh, I've been misselecting things for like 10 minutes here. Little frustrating. Let's flip that around. Okay, I think that's what I want. Let's make it 2 mil thick so that there's room to fillet. Oop. Am I going to be able to get a fillet on this or not? Alright, we'll go with radius. That's better. Let's see if we can get the original one I wanted. Yeah. Okay, yeah, I like that. Let's do a new sketch on this surface. Oh. Okay, get a good view on it. get that wrapped around there. We'll go into 1 millimeter in. Alright, so it's a purity. And this will be that's going to be a huge pain to print. Everything must be round. That's not what I'm asking for. I want the distance between the center. Come on. Give me. There. To there. Alright, so what we're fixing now is the domes being all in the wrong spot. What we're going to do is go back into the model. Into the PCB model and actually move the connectors so they match up with the case we designed. Yeah, I'm gonna see if I can adjust the design to not need... I know how to make the design not need support. I just don't want to do it. No, I've got an idea for changing up the top a bit. What are you complaining about? Go. Oh, we got a dome seat. Exactly. Ugh, one of my sketches is screwed up. Alright. What is this sketch? This is just... the walls. And this is... the holes. That one should be right. This one is wrong. Alright, so this should be good? No. Alright, so we're gonna... go. Okay, slide that sucker over. Come on, offset. Okay, I like that. So that will give us a catch that forces that down quite a bit. So I'm going to have to deal with 4 mil, which this will cover. Okay, so that should sit up in that perfectly. But I need something to essentially hold it in place. I was thinking that I could print separate little bezels to go on, but it doesn't need the lip. But we'll see if it really looks nice after. Alright, yeah, I want to do an undercap cut again. Oh, click. Enter. Fair enough. What, you liked it better with the offset? Alright, I'm going to do a cutout here. This is going to be 3 mil deep. I don't like that. Oh yeah, I really like those, but they're hard to print, so... I'm gonna run off and grab one of my designs from upstairs. All right. Let's grab the close-up cam. So, that design you were talking about where it comes up nicely with that bevel, yeah, I do really like that idea. Because the interface looks quite a bit nicer than... Come here, camera. So... This one's actually designed to hold this. Actually, let's put this together for fun. All right. What do I have hooked up? I have all right, the first pin is ground. So that's plugged in the right spot. Let's give this a little power and see if it's hooked up right before we jam it in the case. So I plugged it in and it fired up. It's now charging its battery. This guy's actually special. It's a distance measurement device, and if I hook up a second copy on another cable, that one's occupied. Alright, so I'll plug this guy in, and that light went green because it detected the Bluetooth signal from this device. So if I take this further away, it will get slightly brighter in blue, and the closer this gets, the brighter the green should be. Now I gotta get this on a longer cable so I can take it away. So if I disable this device, you can't see the light. Where's the light? Where'd it go? What the heck? Is it just too bright? There we go. So this should get brighter and darker. AI researchers are not programmers, and it shows. So, look down here, camera. Alright. Now I'm just playing with random electronics. But I'll disconnect the reflector, and this should get angry. Come on. There we go. It says, hey, I can't find my partner. You got Frigate running YOLO and semantic search? That's awesome. Did that get more blue? I don't know. I hadn't programmed this very well to actually change color noticeably. Oh yeah, the blue's pretty much off now. Not that you can see it, because it's so bright. But as I get further away, yep. Yeah, that is working. Cool. So, It's impossible to see. Oh, I have an idea. I can cheat. Well, that doesn't help. Curses. How about a lens? It's still too bright to show up on camera. But yeah, this is a little battery controlled, well, it should run on battery for a sec. There it goes. So, set that guy down. And where did I leave the remote? Way across the room. So we got a noticeable blue light on it right now. Which should scale down to pretty much nothing. Especially if it falls over. But yeah, when I am right next to it, it makes the green fully bright and the blue fully dim. So, sort of working for a test project I forgot last week. Alright, let's stick this back in its case. This should start blinking red in a sec. You can do it. You can't see your partner freak out. How long until it figures out that it can't find its friend? Maybe it's crashed. I don't know. Let's give it some power. Yep. As soon as it woke up, it's like, where's my thing? And we got red pulsy light again. Alright. But the whole point of that was to show the curve in this design. Alright, I should probably check my million Discord messages. Alright. Yeah, we are at 4 hours and 15 minutes, so I'm going to do just enough to get this top printable. So what I decided it could be used for is a cat collar. There's actually a full copy of the receiver in here. It's just not charged, and it's a little awkward to get the USB cable in. But this is a cap design that I kind of like because it stays in there, but nothing retains it. So even though it stays in nicely, all right. So this should be booted up now that it's got a little juice. Where did I put the other one? This one, it didn't get a lot of battery life out of its 10 seconds of charge. Yeah, exactly. It's pretty precise, about 25 centimeter accuracy. USB cable. Cool. So these two devices are paired together. This is a reflector and this is an initiator. The initiator, actually, I'll bring it up. We can look at what it thinks the distance is right now using a terminal tool, because they're both on USB. This is Bluetooth channel sounding on the Seed Studio Xiao NRF 54L15. Alright, new terminal, serial monitor. Oh yeah, a sensor to turn something on. Of course, yeah. The demonstration they show in the video from Nordic, they use it to show a key getting closer and closer to a lock before unlocking. And, well, you don't have to unlock because it knows, oh, I'm out of hot chocolate and I'm sad. Alright, I'll make myself hot chocolate when I stop streaming in about 15 minutes. But for now, serial monitor. Let's monitor COM19. And there we go. It thinks that it is 0.5. It thinks it's 50 millimeters apart. Let's see. It is about 100 millimeters apart. Actually, it's getting there. Yeah, we got 0.85 of a meter, and it's about 0.85 of a meter apart right now. So I'm just gonna move this over here. It's sitting at about a meter, and it's reading about a meter. Pretty cool. Yeah. Just move my hand a little further away, and then we'll just get closer again. How close do you want to be? So, RTT is like, where are you? Phase is like, you're at 0 meters. So phase is actually correct here. That tiny value it's getting, yeah. But we'll go back out to a meter, and then let's see. I know it fails at 5 meters, just flat out fails. But let's separate these as much as possible without unplugging them. So, the other one is way over here on the keyboard, right here, being all bright and shiny. So, just to demonstrate, I will make it blink red by unplugging the transmitter. It should start blinking red in a minute. There we go. I can't find my partner. Oh no. And then it almost instantly finds its partner again. And it says... So I took the regular channel sounding software, and what it's outputting here is my best estimate from its best estimates of where the thing actually is. So let's see if my estimate of 4 meters is correct using a measuring tape. We're just going to go from the center of my desk to where it is over there and see if it's right. Oh, I bashed it. And we are at about 3.5 meters here. So I'll lock this at 3 meters. Oh god. Measuring tapes. So, yeah, that would be... So that's a 3 meter mark behind the monitor there. So what do we got? I'm just gonna set that right on the measuring tape at 3 meters. I'm pretty satisfied with a reading of 2.8 meters for 3 meters when this is what's going on here. Cable, throwing the tripod. So there's our device down there, and there's our 3 meters away transmitter. And you can tell this is not a clean RF environment. Like, come on. It's a room full of weird gadgets. There's a Wi-Fi hand programmed device back there just pounding away. Dozens of computers and cameras and lights. And the Bluetooth's just like, yeah, it's over there, bro. We're not getting millimeter accuracy or like centimeter accuracy, but within about this much, pretty good. And I have found something delightful that I will share with you all. You can maybe be able to see a tiny bit of it there. Hello, you little delight. Yes, you. This is my kitty, Char. She is an angry little murder muffin. You want to put your tail free? Your tail free? There you go. Yeah. She may look like she wants to get away, but she's purring. And she loves me. Yes. Don't you? No? Are you good where you are? Yeah.
I heard you want cats on the
A cat? Did you bring me another cat?
Another cat. Hello.
Oh.
This one's fluffier.
Oh, this one's fluffier. Wow. Wow. Hello. He's not sure he wants to be here right now. Whoa. Acrocat. A little bit of acrocatics. All right. Thank you, everyone who's come today. My first viewers on YouTube ever. Thank you. Family and friends. And Bob, I hope you saw a bit of what you were hoping to see with the PCB stuff. And everyone on Twitch. It's been a lovely evening. I will be back online tomorrow morning at 10 a.m. Eastern. Similar random format, jumping between programming, 3D modeling, circuit board design, and playing video games. I'll try to have tunes and a big smile on my face to chat with you guys about tech and other stuff. Is it okay to buy a GPU now and store it for 3 to 5 months before building my PC if I'm scared of GPU prices going to skyrocket? Well, let's think about it. My wife's PC is still rocking a GeForce 1080. It's 10 years old. It's awesome, but essentially, yeah, you could get a GPU now and hang on to it if you're worried about the prices going up. They don't really go obsolete that fast. I'm running a 4060, but I saw a 3090 the other day and got excited. I'd rather have that. So, I don't know. If you're going to get a beast of a card, you can let it sit, but maybe it'll work in an older system too. But, I don't know. I'm just a geek. Okay, so let's find us a place to go on Twitch. Right. There's a few good people online. Let's go with Atari Beer Pong. You were thinking of getting a 5070 Ti? Yeah, that'll probably be good. Although I moderate for someone named Sakura, and they have been having a wonderful time with their new Radeon card. So you may want to consider. Oh, unless you're actually going to do AI stuff on it, then get an NVIDIA. Don't bother with AMD because everything's like. When I looked, it was all CUDA. Let's do a couple of shoutouts. I can't even shout out. There we go. There's that one. We got a shout out. I have to wait 2 minutes between shout outs? Dang. A heatsink paste going bad while sitting. Applied heatsink paste should be fine. Heatsink paste that's been in the tube for 5 years is suspect. Alright, we are going to raid over to Atari Beer Pong, a lovely Canadian. Oh yeah, like years and years before the paste goes bad. Hopefully I can spell Atari Beer Pong. That looks right. Thank you, everyone, and have a wonderful night.